Alright, so we have done everything except for just regular multiplication. We did scalar multiplication, now we're doing regular. I made a different video because I want to make sure that you have all the ample time on this one. Now with it, I'm going to link another video or probably put it in the playlist so that you can actually see the other video. I created a video already in the past for multiplying matrices, and it gives you the details of how to do it by hand. It gives you the details of how to do it in a TI-84 calculator. But this time I'm going to do it like abbreviated version of it, a quicker version of it, and I'm also going to show you how to do it in desmos. So that way, like, you know how to do it. If it comes to the ACT, guys, you won't have desmos, you'll have the 84 calculator. So you'll need to go to the other video to actually see where I went and put everything into the actual calculator, the TI-84 calculator. So yeah, I'm going to use desmos here. Go to the other video there and actually see how I put it in the 84 calculator, which you're going to have for the ACT and for other times. All right, so here. When it comes to multiplication, again, dimensions are going to pop back up again. They're going to be very important, very popular for that part. So when multiplication, I'm going to give you, let's say, our matrix. And I'm going to use letters here, and it might get a little confusing, but I'll put numbers there also. Here, matrix A, let's say that gives you a dimensions of m times n. So there's m rows, n columns, RC cola, rows, columns, cola. All right, and then let's say that we have matrix B here, and we're going to try to multiply these together. And these are going to be n times p, or n by p, sorry. Not times, but by. Again, these are rows, these are columns. In order to be able to multiply, something must happen. If this does not happen, you automatically stop and say, Mr. Hall, this can't be done, and the problem's over with. Whenever you're looking at your dimensions for these two matrices, the two inside pieces must be the same number. They must be the same number. If they are not the same number, you can't do this. You automatically stop right there and say, done. Mr. Hall, can't be done, done, and then leave it. If they are the same numbers, that's amazing. That's wonderful. That's what we need. Your answer is going to have the dimensions of this outside part. So your answer is going to have a dimensions of m by p. If your inside works, if they match up, it means you can go ahead and multiply it. You can get it. But your answer will be the shape or the dimension of m times p. Now you see letters there, and you're probably like, Mr. Hall, like, that doesn't make sense. Like, what do you mean? Like m and p, n, whatever. So let's go to, and I'm going to call this a for example, not an example, but a for example. Right, for a for example here, we're not going to multiply it out. We're just going to talk about our dimensions and to see if can it be done, and if it can be done, what is going to be the dimensions for the answer. All right, so with this, I'm going to give you guys a small one here. So I'm going to do this with you. So this is going to be 1, 2, 3. And B is going to be 4, 5, 6. Right. And right, the big part here is, again, we have to write down what are the dimensions of both of these. Rows and columns. So here we have one row. So this is a 1 by 1, 2, 3 columns. So 1 by 3. for B here, we have 1, 2, 3 rows in one column. RC cola, rows, columns. All right. So, these two right here are the same. So since they're the same, we can multiply this. It can be done. It can be. But our answer is just going to be a matrix that's a 1 by 1. So if that part on the inside is not the same, you stop there and say it cannot be done. If it is the same, that means whenever you multiply it out, your answer is going to have a matrix that looks like this, a 1 by 1 or whatever M and P are. All right, cool. So that might not make a lot of sense right now, but let's go to an example where we talk about this and we work this bad boy out here. Now, with this example 5, I'm going to go ahead, still do it with you because I'm going to give you a website that we're going to look at, which is the Desmos website. And we're using this website again for Desmos because I know everybody in class does not have their own TI-84 calculator. And because you don't have your own, we have to do something that everybody has, an equitable area, or something that's equitable for everybody. So here we're going to do A's 2, 3, 4, 7. Matrix B here is going to be 0, 1, 5, 6. All right. So first and foremost, if you need to pause it so you can actually write it down, go do that. Before we do anything, we said dimensions have to be the same. But before we do that, let's not do that yet. Let's go ahead and come here. So A, we're going to use these two matrices. For B and C, we're going to use two other matrices. So if we look at this part here for A, now for B, AB, look at our dimensions. This is 2 rows, 2 columns, so a 2 by 2. This is 2 rows, 2 columns, another 2 by 2. So again, these are the same. So our answer matrix is going to be a 2 by 2. Our actual answer will be a 2 by 2. All right. So with this, what we're going to do is we're going to go into Desmos. We're going to go to that. But you can't just say Desmos and that's it. Desmos.com and that's it. Here, we're going to have to go to desmos.com/matrix. Again, desmos.com/matrix. So if you type that into your line up top, your address bar, it'll pop up with the matrix that looks very similar to what we're getting ready to do. All right, so if you put it in desmos.com/matrix, it brings you to this page. So what we're going to do is we're going to pull up our matrices here. So matrix A we said was 2, 3, 4, 7. So we're going to click new matrix. We're going to put that matrix in. 2, go over 3, go down over 4 and 7, and we're going to hit enter. So that's our matrix A, 2, 3, 4, 7, just like we said here. 2, 3, 4, 7. All right, we're going to click on new matrix again. This is going to be B. It's going to be 0, 1, 5, 6. We're going to hit enter again. So now that has set A to be 2, 3, 4, 7, and B has been set to be 0, 1, 5, 6. So to make this easy, we're going to multiply A times B. So we did A times B. We're going to hit enter, and you can see it right there already. So here, we're going to write that answer down. So our answer is a 2 by 2, like we said it's going to be 15, 20, 35, 46. And that's our answers, guys. That's our answer for that. Easy, simple, not hard. We got this. That's all we know what we're doing. Yes, you do. Yes, you do. All right, so then let's go to B. And we're going to throw in two other matrices here. Ooh, I want to see that. All right, two other matrices. And let's pull this back up. I'm going to go to another page really quick. All right. B. So this is 4, 2, 1, 3. And this is 1, 2, 3, 4 on top. And a 0, 2, -1, 6 on the bottom row. All right. If we look at it, this is going to be a 2 by 2. And this is going to be a 2 by 3. You might be like, wait, those are different dimensions. We're not going to be able to do this. I beg to differ. Sorry, 2 by 4. Sorry, 2 by 4. Not 3, but 4. My fault. 2 by 4. Again, these are the same. Since they're the same, your answer is going to have a matrix of 2 by 4. So in the calculator, again, we're going to go ahead and type in the matrices, but it's important that you do your dimensions here because that's going to be important for when we have to put it in. So we're going to make these matrices C and D. So C, it's a 2 by 2, like we said, so we have to do 4, 2, 1, 3, hit enter. But matrix C D here, I'm going to click new matrix C again, it's a 2 by 4. So 2 rows, we have to do 4 columns. So do 1, 2, 3, 4. 0, 2, -1, and 6. All right, and what we're going to do is multiply C times D. Hit enter there. Hey, and it's a 2 by 4 like we said right there. So it's 2 rows, 4 columns. So here, our answer is going to be a 2 by 4, 4, 12, 10, 28, 1, 8, 0, 22. All right. Now our last one, all we're going to do is flip things around. So we're going to use the same two matrices we have for B, but we're going to switch them. All right. If we switch those around, we know, okay, this is a 2 by 4. This is a 2 by 2. And guys, this is not the same thing. So this cannot be done. So when you do it, guys, this one won't be done, so you just have to leave it as it is. So we say cannot be done, and that's it. So it's important that you have your dimensions and you know how to find them. Because if not, you'll be doing extra work. So here, what I'm going to do, I'm going to do D times C. Clear it. D times C. I'm going to hit enter there. And there's an error right there. Why? Because we cannot do it. Cannot be done. All right, and that's it, guys. That's all we have to do here. So that's matrices. Good job. Good job.